Welcome back. In this part we will study microarchitecture for store word SW instruction. And before going to the lecture, I think that you guys already studied the load word instruction and also watched the video that in this class that regarding the solution of Enshimondai 7 for the class. So that this video is starting after that. That means considering that you already know the data path of load word instruction. Well, let's move. And here is the instruction: SW register 1, offset register 2. This is the format. Now we will extend our data path for load word instruction that also support the store word instruction. So particularly a store word instruction stored the value from one register to a particular memory location. This part, we will try to understand the data path in the microarchitecture for the store word instruction. So here you can see that the value read the base address from the T1 and sign extend immediate for the 4. These two combinedly make the memory address where you have to write the value from this. So the ALU perform the base address to the immediate field, the memory address. So the arithmetic logic unit add these two parts to find out the memory address, same as LW instruction. Here the new addition is, instead of loading data from the memory, the store word instruction read a second register from the register file and write it to the data memory. This is the 32-bit instruction in binary. So the first part is the instruction and the register T1 and the register S1. So this register is used to get the value of base address from the memory, and this register is used to get the value that you need to store to the particular memory address, and these are the offset value. So in the microarchitecture, the first address calculation part can be used as it for the load word instruction that I take. It's the same. So and then the register is specified in a RT field, the specific bit number 16 to 20 for the instruction. This bit of the instruction are connected to the second register field where the port A2. So these are the basic steps, same as the initial 1 to 4 is the same as the load word instruction, face instruction from the memory, read source operand from the register file, sign extended the immediate, compute the memory address, and now instead of write the value to the register, it read a second register from the register file and write to the data memory. Okay, let's have a look at the each of the steps here. The first, the memory that is stored in the program counter. Here in the program counter, you will get this instruction like this: store word S1 for T1. And the second phase, source the operand. So here is the operand for the register that used to calculate the memory, and another operand that is to write the address from the register. Okay. So the sign extend part, take the immediate and extend it, the sign immediate, to get the memory address, same as the load word instruction. Well, so here you get the first source that contain the offset base address, and here is the offset. So the ALU control is for adder. So these two are added to find the memory address. Now up to this, it is totally similar with the load word instruction. What is different? Now we have the memory address, so now we need to write this data of the S1 to the memory address here. So the S1 data is read here, the port 16 to 20, and the output, that means the data contain the register address S1 are write to the memory address. And here be careful, not like the loadout instruction. Here the memory write flag is 1, that means you use the read port to write this memory. And then to determine the next address, the program counter are increased by the 4. This is common. Well, now what is the basic difference and basic addition of this data path? Well, so the load word instruction read memory, write data to the register file. And the store word instruction read register file and write to the memory, just reverse. And so these data part are modified with this data path for the loader instruction. So here A3 port is used to write the register file. Instead here, so A2 is used to write the memory. And the memory write flag is set to 1, and here is not. And the remaining part, like the calculating the memory address, the sign extension are same. So this is the way that the store word instruction works, same as load word instruction. Well, let's have an example. So once you started the example, you guys can easily understand the difference in all the things for the store word instruction. Well, I'm giving you that the program counter is this, okay? That means the instruction of store word are stored in a memory address of this. Well, so the 32-bit binary address of this instruction is like this, because you know the address of the register V0 and the T0. Here is it, and you will go to the position. And one more thing, that you are working to store word instruction, so you need to store the value that contain this register. So you must need to know what data that contain the V0 register. And here I give you that suppose V0 contain this value 0000000A. Well, one more thing you must know, to calculate the memory address where comes from these two value, the offset is C is here, and you must need to know what the value contained in T0 that should consider as a base of the memory address, right? So I also give you that value, the T0 is this. So if you add this T0 with C offset, you will find the memory address where you write the value of T0. Okay? And I've also given another thing, that the existing value of the address of this is 0xFFFFFF. Well, now let's come to the point. The first thing is, so the calculating the address. So the base address is 4 and the offset is C. So 4 plus C in decimal is 10 here. So we'll get the memory address here 10. Now we need to write the value 00010 is the address of V0. So V0 comes here. That means in this path you will get the value here 000A. So the 000A is here. The memory write flag is 1. That means you're writing the memory address here. So the address 1000. Earlier it contained this value FFF, but after writing the value is changed to the 0000A. That means the stored word instruction stored a value of this to a particular location memory address that contain this value, that already contain this value FFFF. So this value is now changed with 000000A. This is the basics of store word instruction in detail. So I think you guys understand the store word instruction. Okay, the next is R-type instruction. That is another video. So until this, Please have a look on the next video for R type instruction.